Hi guys, welcome to the video. This is going to be a tutorial series on using DevFus Foam 2. I get quite a lot of feedback from the website with people asking various questions about it, and as you can see from the website here, it says it's a simple program, but I suppose simple is a relative term really. It's not one of the easiest programs to use, but the more you use it, the better you get at it. Here's my Hawk Hurricane made with DevFus Foam, the previous version. So I'll put a link up for that so you can have a look at that one, give you a bit more idea. There's been quite a few updates to DevFus Foam 2, and it's got some very useful options now. The thing is, you might ask yourself, why would I use DevFus Foam 2? Well, really, it's a way to produce fuselages for RC aircraft, probably a lot quicker than traditional methods. But the only thing is, you really do need a CNC machine to do this. So there's a couple of ways to do this. You can use a hot wire CNC machine, or you can use a CNC router to create all the formers and then run a bow over it. Potentially you could actually just print off the formers that are generated and then cut them out manually, but that's be quite a long process. So there's going to be 4 videos in this. This first one is just an intro really, just to show you what it's about and whether you want to carry on watching the series. The second one will go into actually scaling an image for a BAE Hawk, which we're going to model, and then produce the outlines and the formers. The third video will go into doing the wing slots and the canopy slots, which are new to DevFus Foam 2. And then the fourth video we'll actually make it and see how it comes out. So stick around if you're interested. So this is the image we started with, and this is a real good image. It's got lots of section cuts. So what we'll do is we'll just start up DevFus Foam 2. And that little delay there is when it's checking for the license. So if we just close the project management screen, you can see there we've got a licensed version. If it wasn't licensed, it would say unregistered. So I'm just going to do a quick overview. I'm not going to go into details in this video, and just show you what we can achieve, and then you can decide whether you want to watch the rest of the series. So the main page you come up to is the projects page. So on the projects page, there's some example aircraft on there that are quite handy to look at to see how things have been done. The one that I found very useful to do the Hawk is the Mirage, especially around the jet intakes. So you can see on the buttons on the side we've got various things we can do. So this is the design side and this is the cutting side. So we can create a new project, modify, delete. I tend to use clone quite a lot. Now, I have exported projects to a file just to save them somewhere as a backup, and then you can re-import them back in. Now, I have done this with, you look down the bottom here, had a guy that was having, a guy called Chris Bailey, was having some problems with a vampire that he was trying to model with DevFus Foam. So he sent me his file, and I then put it into my DevFus Foam and had a look at it. So when you first start it, you would create a new project, but what we'll do is just show you what can be done. So the one that, my main one at the moment is the BAE Hawk version 2. And we're going into modify, so we're just looking at all the basics really. So the first screen is where we set the sizing up, and what we have to do is scale our drawing to do that, and we'll do that in the next video. Then we set the images, so these images are taken from that image there. So they're just cropped out. We do that within the program itself. And for some reason it shows one of them bigger than the other. I don't know why it does that, but it doesn't seem to affect it. And then what happens then is we do the outlines. The dimensions you gave it at the beginning, it tries to get somewhere near with the shape, but you'll see when we go into the actual detailed tutorials that to start with, it's nothing like that, and we have to manipulate that shape. So we're just going to edit actual outlines graphically, and we can use these nodes to pull things around and get a good shape. So the first thing is we get the outlines, and once we've got the outlines, we then go into edit the formers. There's another screen before we get here asking you for the size and the type of formers, but we can go in and we can edit the formers, and then we can apply background images as well. So we go into former number 7, going to edit full screen. We can actually manipulate the formers to follow a background image. This part of the program is probably where you'll spend most time trying to get the formers correct. I spent hours in here. So these are all the formers. If we have a look at a 3D preview, so this is a shape that's been generated from the outline and the manipulation we've done on the formers. So it's not looking too bad, that. And you can see we've got different widths here. So these widths here are 60mm, which is the size of foam I use. But some of them we have to actually alter the width. And this one at the back, I've done it as a real wide piece, so that we're not having all the individual formers to glue together. So this next section here is where you can alter what's called the Syncro Points. And what the Syncro Points are is the path that the wire takes on 2 pieces. So just have a look at 3D preview. So if we have a look at formula number 7 and 8 and go to the 3D preview, and the Syncro Points are the path that the wire's taken on each former. What can happen sometimes, if there's a very big difference in shape, it can sometimes slow the wire down and you can get a lot more foam melted away. So you can go in there and alter that, but I haven't found the need to do that yet, but possibly on a more complex model you might need to do that. So generally I just leave that section alone. Sheeting section, if you want to cover the fuselage in some like a balsa veneer. The spar section, you can add spars to the fuselage, which is quite handy for lining them up, but for doing this BAE Hawk, it's not going to be very helpful because the spars will just get in the way of where we're trying to do things. So I've just ignored them again for this model. With this section here, we can apply lightning holes, and this is quite a handy section because you can see, I'll show you a quick overview of what I've done on this Hawk. So on 1 and 2, there's no lightning holes, but if we go on to 3, 4 and 5, so I've cut them out. So that's going to be where the battery and some of the gear fits in. If we go on to 7, 8 and 9, 10 and 11, this is where the EDF fan's going to be blowing through. So the fan's probably going to be sat around probably this former here, number 8. I haven't cut any holes out here for the jet intakes yet. I'm going to do that manually because there needs to be a little bit of shaping of the fuselage once we've got it out of DevFus Foam. Because you're cutting with a straight wire, so you're only getting straight edges. So, and these jet tubes that are a little bit round at the end, so that'll be done manually. So if we have a 3D preview of that, it does take a little while to generate this, and probably because of the screen broadcasting software I'm using, that's slowing it down a bit as well. So if we spin it right round, you can see the jet tube at the back, and you can see some of the square holes at the front. So this has taken quite some time to get this looking like this. So if we go on to the next section, and this is where we can do wing slots. On the original version of DevFus Foam, it didn't have this. So basically I just had to eyeball it. When I did my Hawker Hurricane, I just had to make some templates up and work out as best I could. So I haven't actually tried this option yet, but what's quite good with this as well, if we go into each one, you can actually specify an airfoil, and I've decided to use MH42 on this. And basically what you do is you work out the distance from the nose, the chord length, and then the position up and down. And you see we've also done that for the tail as well. And this is just a symmetrical airfoil on the tail. It doesn't look like it goes all the way back there, but when we go into the later videos, I'll do some more explanation on that. And then we can do a 3D preview and have a look at them. So as we spin it round, we can see where the airfoils are going to go through. So what's going to have to happen is when we cut these, we're going to have to put the blocks in the CNC machine, and it's going to go through and cut these out. Hopefully I've got them in the right position. So then on the next section, which is also new to DevFus Foam 2, we have a canopy slot. And basically what you can do here is put a canopy in. And I've done this in 2 sections, and I may change it to 1 to make it a little bit simpler. Probably doesn't need to be 2 sections. If we do a 3D preview of that, there we go. So there we've got the canopy, and we can also see the lightning holes in there as well. So this is where the battery is going to go, and that does go back a bit further as well. I'm quite interested to see how this is going to turn out. So that's the design process finished. So we can have a look at all the elements here, which is basically what we've just been looking at. So you can see, so if we put the drawings back on, it's not looking too bad there. And the beauty of this is if you decide you wanted to make a much bigger model, all you'd have to do is go into it again and just alter the sizes, and yeah, you can have a larger version. This section here is also new on DevFus Foam 2, which is called Expert Mode. On the original version, didn't have that. So if you did anything, you had to go right through to the wizard so you could save it. But now you can just go to different sections. So you can go to lightning holes or room slots. Back to the Syncro Points. And what I like about this is there's a save option, so you can save it every time, and then we just go to the last and finish. So that's the design section finished, and now we've got 3 options now to produce the parts. First one is the one I use, is a hot wire CNC machine. The other option you've got, you can cut all the former templates out with a 3-axis CNC milling machine or CNC router, which are quite popular. Or the other option you've got, you can just print all the parts out and then cut them out by hand and just use a hot wire on a bow and cut them out that way. So that's another option. So we'll just have a quick look at the CNC 4-axis. So first thing you have to do is select the parts you're going to be cutting. So we'll just select, say, we'll just do 2 as an example. We'll do 7 and 8 there, blocks. And all I do is run the wizard. When you first come into it, it'll probably be that way, and the hot wire will come in from the top. So rather than having this piece with a slot in it, which needs to be filled afterwards, I prefer to have them upside down. So there's only a small piece there that's easier to glue back. And there's a few options on here how far you want them apart. Generally I find that most of the default options here work just fine. So we go on to next. So this is the curve setting, and this is how much wire is going to be melted away by the cutting process. I prefer to use very thin nichrome wire, And by using very thin nichrome wire, I don't have to put a lot of current in there. And it means if it does melt anyway, it's not a vast amount. So I think the nichrome wire I use is about 0.6 of a millimetre. But what you can do, you can alter these values if you're finding that you're using a thicker wire and it's melting too much away. So you can adjust the cut speeds. But again, these I find these settings work quite well. And this is a view of your hot wire machine. So the red there is the distance that the actual wire will have to move on each end. So sometimes you can find if you've got more parts on it, you haven't got enough travel. But what you can do sometimes, if you can move these closer together, which means then you'll have to alter your wire and retension your wire, you can get more parts. And sometimes you have to do that if some of the parts are very steeply angled. When I was doing my Hawker Hurricane, I found that I had to do that on the canopy section. I had to have the towers quite close together. But you can modify your settings here as to the size of your machine. And when you've done that, quite a lot, as if I've made any changes up here, is just test the path limits. It's okay. If it can't do it, you'll get an error there and you'll have to go in and make some changes. And this is telling us where we need to place the block, the X and Y placement of the foam block. And what we can do then is have a look at the simulation of the cutting. So we just spin this around. So these grey sections on the end are the actual path the wire's taken right at the end. So I just tend to switch them off anyway, so get in the way a little bit. And it always starts at the end rather than the beginning, so if we just go back. So this is our foam block, and then what we can do is if we do it slow, this will be a very long video. So press fast, and it's showing us what it's going to do. So it does the inside first. So this is going to be the jet tube on these. And then once it's done that, it goes on and does the outside. What you want to make sure you do though is don't throw away any of the parts, because when we come to do the waste parts that are in the middle on that, because what will happen is, especially on the block as well, because what we'll need to do is stack these blocks together for doing the canopy and the wing slots. So it's just going to go off and do another one there, so I'll just stop that. So there you can see that's what we should end up with. And it's just telling you where the block needs to go on there. This section here is just for pre-cutting the foam block. But to be honest, I've never used this section. And I leave everything as it is here, and all I do then is go to create the 4-axis G-code file for both carriages. There's an option there, but again, I haven't found any need to use that. You can have a look at the help file about them as well, but DevFus Foam 2 is quite a complex program, and so I tend to try and use all the defaults where possible. So if we go to now this section here, if you're using the demo version, as soon as you hit that create 4-axis G-code for both carriages, it'll pop up a license option. So you can do everything apart from save the actual G-code. But so what we'll do, we can put I think this was 7, I think. So this is just a description. This is quite handy for when you take it onto the hot wire machine and it comes up, so you know you've got the right file. Because when you've got a load of G code, it doesn't look very descriptive. You can also change your axis here, so if you've got a different setup on your axes, you can change them here. And then once we do that, we say OK. And it asks us where we want to put our G-code file. I'll just put it there for now. And if we have a look at that file, as you can see, we've got the begin header section there. What we're missing now, I should have put a semicolon in there, otherwise we'll get an error. And this is all the G-code that's generated. So not very interesting to look at, but hopefully it can produce our parts for us. So we've also got the wing slot, and that's a very similar process. And so the wing slot, again, what I'm going to do on this is revert it. So, and you can see here it's going to tell us the blocks that we need to do this. So we need blocks 5 to 9. So what we'll have to do is get all the blocks together and get the wing slot, get them in the CNC machine and get this wing slot cut out that way. So if we have a look at the simulation again, so that looks pretty straightforward there. So if we go back, run that again. So hopefully that one shouldn't take too long. I can see the thing that's going to be interesting on that is getting the blocks lined up in the correct position. Probably do a dummy run first with some scrap foam and see where I need to line it up with. And then the canopy slot, similar process. And it's telling us we need blocks 3 to 8, and then telling us the offset of the block from the, so it's giving us some other settings there that we need to bear in mind. If we do a, let's take them off, run it back to the beginning. And so that should be fairly quick again. And then we'll just then create the G-code. And the other option we've got is to draw, print and export the parts. So if you were just doing this by hand, this would be the section you go to. You've got some options here. Again, I haven't used this very much, so they're all the parts there. We'll do finish on that issue. So we could then come into this section here. So one option we've got is to export to DXF, and we can print, do a print preview. That's one option, is you could just print one of them out, glue them to some, probably some ply or something, or probably some aluminium, probably thin aluminium will be better. That sounds like a lot of hard work, that does. So the other option we've got is to cut the parts out by a 3-axis CNC milling machine. So this is just going to give us the formers which we can run a bow round. So I won't do all, let's just do 7 to 11, that'll do. Then you can put the dimensions of your material in there. And then you tell it the size of your cutting tool. And you can also put labels on them. So there's various parameters here you can set. You can say you can apply bridges to the a cutty path as well, so the parts don't fall out. So there's our parts there. So we do a few, and then we come into the generator and the toolpaths here. I haven't used this option, so it may be useful for some people, this, but the tutorial is really about using it for a hot wire CNC machine. But you can see there is possibilities there. So this was a quick test I did a little while ago when I was thinking about building the Hawk, just to get an idea of what size the fuselage was come out, and actually this was a little bit too big. This was these two of the parts, and when I worked it out, it was going to be much too big for the fan I intended to use. So I've scaled it down a little bit, and then afterwards I thought I'll not just do it as an outline like it is here. I'll actually do it with the jet tube inside. But it was quite useful just to make sure things were coming out as I expected. So that concludes the overview. So in the next part of the series, first thing we'll do is we'll scale our image so we can get the correct size, and we'll use DraftSight to do that. But you can use other programs. This is just one I use, and it seems to work quite well. And then once we've scaled the image, we can take some dimensions and then feed them into DevFus Foam 2 to get us going. And we'll carry on to do the outlines and the formers. And then in the following video, we'll do the canopy and wing slot. And then in the fourth video, we'll actually go and make it. So thanks for watching, guys. Please like and subscribe if you wish to, and catch you next time.